All right, so we're going to graph this line and this parabola on the same coordinate plane. Now, this first equation, hopefully you recall y equals mx plus b from graphing lines, pretty basic. And b is the y-intercept, so we start with that point. So you go up to 6 on the y-axis, and that's your y-intercept because it intercepts or crosses the y-axis at 6. And m is the number in front of x. That's our slope. But since there is nothing in front of the x, we'd put this invisible 1 there. And we always want slope. We always think of it as rise over run. So to make it a fraction, you also put it over 1. This is the nice, easiest slope we can ever work with, 1 over 1. So from that first point we plotted on the y-axis, that purple dot, from here I'm going to jump up 1 unit, and I'm going to go right 1 unit and put a second dot right over there. So up 1, right 1, there's a dot. And continue that, up 1, right 1, up 1, right 1, all the way. And remember that you can also reverse both of those directions to continue graphing the line in the opposite directions. So I can go down 1, left 1, down 1, left 1, and continue that throughout my graph. So once you've got all these points, go ahead and draw a nice straight line, as straight as you can, through those points, and that is graphing a line. I'm pretty sure you're all professionals at this. Now the next graph is a parabola, and we've graphed those for on our or one of our last learning targets. And but if it's just that basic parent function, it's pretty general. You've got the vertex at the origin 0, 0. And then if you want, you can draw in like that axis of symmetry. If you want to help remind yourself that whatever's on the right side will be reflected over to the left side. And then if you go right 1, you're going to go up 1. And that's because the y value, right, whatever the vertical distance is, that's the y value. It's whatever the x is, or the horizontal distance squared. So since 1 squared is 1, when the x is 1, the y is 1. But if I go right 2, so on my graph, if I'm looking at the 2 right here, if 2 is my x distance, well, what is 2 squared? Well, 2 squared is 4. That means 4 would be my y value. If I go to 3, well, 3 squared is 9. So 9 would be up here. And I can do the same thing in the opposite direction, because when you square a negative, it becomes positive also. Or you can just simply reflect all these points over that axis of symmetry. And you've got all these points right here, and go ahead and draw in your parabola. It should be curved. These shouldn't be straight lines. It's not an absolute value function. And so there's a line and a parabola graphed on the exact same coordinate plane. Dun, 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 dun. Today's lesson is on solving systems of equations. Well, we've done that before using like substitution or elimination or graphing. So this is actually going to be a repeat with one change. One of our graphs, just like in this warm-up, is going to be a quadratic. But the end result is the same. Just like when we solved systems of linear equations, our goal was to find that intersection point, right? Wherever two lines would cross. The difference here is, check it out. With a quadratic, we can have two lines that are, or 2 points where our lines intersect. So there are two solutions for that system of equations. And I can take either one of those points. So this coordinate here, which is 3, 9, or this point down on the left, which is -2, 4. And I could plug either of those combinations in to both equations here on the left for x and y, and they would both come out true. So if I plugged in the 3 and the 9 here, so 3 for x and 9 for y, well, is 9 3 plus 6? Absolutely, right? 3 plus 6 is 9. That's true, it works. And does that same coordinate work in the other equation? Well, let's see. If x is 3 and y is 9, is this a true statement? Well, yes, it is, absolutely, because 3 squared is in fact 9. So that also works. And if we plugged in the -2 and the 4, we'd get the exact same solution. So that's what we're doing here. That's what today's whole lesson is. It's solving a quadratic linear system. And so remember, the word system, when I talk about a system of equations, it simply means two or more equations. And the one difference being from when we learned this earlier in the year, back in Unit 2, maybe, Yeah, unit 2 is that instead of graphing 2 lines, one of these is going to be a parabola, so it's curved. And so we can have more than one solution, just like in that warm-up example right there. All right, so that's where we're going today. Now, we want to think about these two questions here. All right, how many possible intersections can a line have with a parabola? So everyone at home, just go ahead and use your hand, hold up with fingers. How many possible solutions could we have with a parabola? How many times could a line intersect a parabola? Go ahead and just use your fingers. Just hold them up to your camera. 2. I see a couple 2s. Yeah, I mean, look at the warm-up. Didn't we have 2 solutions here? Right? 1, 2. So we had 2 solutions for this. But do you think we're always going to have only 2 solutions? The mystery unfolds. And speaking of these multiple solutions, how can we identify those intersections? Well, that's what today's lesson is going to be all about. And you're going to find out that it's pretty much the same thing that we did in our Unit 2 with solving 2 lines. So there are 3 methods that we're going to go through, just like the same 3 methods that we used when we were solving systems of linear equations. Now, you don't need to jot down each of these equations up here. What I want you to write down in your notes should be the method name. Okay, so method 1, graphing. And then don't bother writing out like these, whatever the 2 equations are. That's just there for your own reference. But what you should do is just sketch a really quick graph of each of these possibilities. So we're not always going to have 2 solutions. That is the most common result. So if you look over here on the left side of the screen, this is the situation where you have 2 solutions. We have a parabola that crosses a line 2 times, and that's because the parabola is U-shaped. It bends down, then it turns around and comes back up. Or it could be upside down. You have the same thing. This is also just like the problem in our warm-up. So that's one scenario. Go ahead and you can just draw a parabola and a line going through it. Technically, you don't even need the coordinate plane to represent this. So you can just do a quick sketch like, okay, there's one line and there's another line, 2 solutions. All right, what about one solution? Okay, sometimes we can have just one solution, meaning only one intersection point between these 2 equations, between the line and the parabola. And you can see that scenario happening right here, where you've got a parabola and a horizontal line that just kind of, bounces off it almost, or it's like the parabola is bouncing off the line in a way. You're just barely grazing it. Now, it doesn't have to be a horizontal line either. I could have a parabola like this, and I can have a diagonal line that just barely touches, like right here. It just kind of glances off the top of it and brushes past it. So if it doesn't actually go all the way through the parabola, it can still touch that parabola at one single point. And if that were the case, then we'd have only one solution to this system of equations, meaning there's only one ordered pair, like one x and y value, that would make those 2 equations true. So only one solution. And finally, we have a scenario where there are no solutions. So if there are no solutions to a system of equations, such as these 2 equations there on the top, that means that there's not a combination. There's not a point, an x and a y, that I could plug into both equations to make it true. It just doesn't exist. It can't happen. And the reason being is if you look at the graph, it's a nice visual representation of why there's no solution. And you can just see that, well, there's this gap in between the 2 of them. And this line is going to keep on going up, in the right, in that direction. Whoa, didn't mean to do that. And in the opposite direction, whereas the parabola is going to just curve up and away, and it's never going to come back down to hit that line. So these 2 both go on forever and ever, but they're always going to be apart from one another. They're never going to meet up. And so because of that, there's no solution to this system of equations. So sometimes we won't have an answer. And your answer is no solution. And if that does happen, remember that we do have a fancy symbol for that. It's a circle with a slash through it. So that means there's no solution to this system of equations. If at any point you've got a question or something you want me to go over again, or if you just need me to slow down because you're still writing something down, simply raise your hand in the meet, or you can just unmute yourself and just say, hey, Wojcik, or something like that, and slow down, and I promise that I will. But I won't always see your hand if you just like physically raise your hand on the webcam, because I'm going to be up at the board. But if you use the hand raise button on the Google Meet, it makes a little sound, and hopefully I'll be able to hear you. And if not, you can just unmute and be like, hey, hold up, can you go over that again? Sound good? Awesome. Can you give me a thumbs up if you're ready to move on? Okay. So that's the first method of graphing. Just like we did in the warm-up, you'd graph the line, you'd graph the parabola, and you just basically visually look, okay, where do they cross? Where do these cross? Where do those cross? And you write those ordered pairs as your solution. Method 2 is the elimination method. Now, with the systems of linear equations, we would do this where we'd set the two equations up in like a standard form. You'd line up the y's, you'd line up the x's, you line up the constants, and you basically add the two equations together so that one of the variables, either the x's or the y's, would cancel out. And then once one of those variables canceled, you'd solve for the opposite variable, the one that didn't cancel out yet, and you would just get a number for like x, for example, and then you'd plug it back into any equation to get the y value, and that ordered pair would be your solution. Well, with the linear and a quadratic system, we're going to do the exact same thing. We can also use this elimination method. We're going to add these two equations together, because the one up top, see how it's got that x squared in it? So this squared right here, that makes this a quadratic. And this one down here doesn't have an x squared, it just has an x, meaning that's a linear equation. So that's just a line. So it's a parabola and a line. We want to find where they intersect, what that coordinate is, but we don't want to have to graph it. And so instead of graphing it, we can just use the elimination method. So go ahead and write these two equations down, and then we're going to walk through it together. Or if you're feeling pretty saucy, you can go ahead and try to solve them yourself before I jump into it. That's fine. Okay. So with this elimination method, we know we want to eliminate either the x's or the y's. Now, with a quadratic function, we have to take this x squared into account. Because let's say, for example, that we wanted to eliminate the x variable. Well, I could do that with like this 11x and 12x. I'd have to multiply them each by, 12 or 11 respectively, get giant numbers, and then subtract them. They'd cancel out. But no matter what I do to cancel out these x terms, for elimination to work, I would also have to cancel out the x squared term. But unfortunately, since this equation, the second equation, doesn't have an x squared, I can never cancel this out. I won't be able to add like the opposite amount of x squareds, right? Because up top, I have one x squared term, but down here, I don't have anything. I don't have any x squared, so I can't cancel it out. I can't eliminate it. This actually is going to make things a bit easier for us as opposed to the linear equations. Because with the lines, we got to make a choice. Should I eliminate the x variables or the y variables? Well, with a quadratic and a line, our only option is to eliminate the y variables, because I can't cancel out an x squared if the other equation doesn't have an x squared. They've got to have the same terms of each type of variable. So instead, This has just a regular y, and this equation has a regular y. That means I can cancel those out. So we're going to add them up, but one thing we need to do first is if I added these up right now, just like this, well, a y, and if I added another y to it, I'd get 2y, and that's the opposite of what I want to occur. I want them to eliminate. So in order to do that, I'm going to multiply one of the equations. It doesn't matter which one. You're going to multiply everything by simply a -1. Because if I do that, that's going to make the second equation a negative y. Then this will be a positive 12x, and this will be a negative 36. All right, let me move this over a little bit. So positive 12x and a negative 36. So all I did is I took that second equation and I multiplied it by a -1. All you're really doing is flipping the signs. Like, you don't even need to rewrite it necessarily. You can just kind of put the negative plus negative if you want to do that. Normally I do that little shortcut, but I wanted to take my time to show you each little step. Now I'm going to cross this out to remind me that, hey, I'm not using that equation anymore. I'm using these other two equations. And now we're going to add them up. Okay, so I'm going to add up each column, basically, of terms, but you need to make sure that each term is lined up with its other terms. Meaning, I've got the y's grouped up in a column, I've got the x terms in a column, and I've got the constants lined up in a column. They're all like right above each other. So now when I add a y minus y, I get 0y. Now I don't need to write the actual y variable right here because 0 times y is still 0. So all you want to do is just write the 0. And we do need that 0 in there. 0 is a number. It's going to be part of our solution after adding them up. But what about the x squared term? There is no other x squared term right here. If you want, if it helps you out, you can think of it as, hey, there's actually 0x squareds here, and you could actually write in a 0x squared, but this is 1x squared plus 0x squareds. I still just have 1x squared. So really the easier thing to do is to think about it is if there's no other term, you just drop that down. Just bring it along after you add them up. Okay, next I've got a negative 11x and a positive 12x. Well, that's going to equal just a regular 1x. I don't need to write the 1 in front of it, but we know it's there. And finally, we've got the constants. There's a negative 36 and another negative 36, so that's still going to be negative, and you add those two numbers together, and you get 72. Hooray! We did it. We solved. No, wait, we didn't solve anything yet. Looks like we made it more complicated. Nah, not really. The purpose of this elimination technique was to eliminate one of the variables. And if you look at that line that I've got drawn right now in red, is there's no longer a y variable. We eliminated the y's, and all we have left are x's. But what's a little bit different now is that there's an x squared term and an x term. That means this is a quadratic equation. Oh, geez. I hope I know how to solve a quadratic equation. Guess what? You do know how to solve a quadratic equation. We can use factoring. We can use completing the square. We can use the quadratic formula. We have all these options we can use to solve a quadratic equation. Now, the easiest and quickest way to solve any quadratic equation is to try factoring it. So let's see if that'll work here. So remember, factoring is when you break this trinomial up into two different smaller binomials. And you want to think of, okay, x and x are going to be there because you have an x squared. But this is where you play that little game. I need two numbers that multiply to negative 72 and that add to, well, technically there's a 1 there, a positive 1. And so this is factoring. You should be awesome with this. We had this on our final exam for that target 5.2. You had to do this. This is also a key skill that you learned back in Algebra 1. So two numbers that multiply to negative 72 and add to 1. would be 8 and 9, but specifically it would have to be a positive 9 and a negative 8. So x minus 8 and x plus 9. So all I did is we just rearranged those three terms, that quadratic trinomial. We just split it up into its two individual factors. And then your last thing for your actual solution would be, okay, if x minus 8 equals 0, well then x would have to be an 8. Or if x plus 9 is a 0, then another possibility is for x to equal a negative 9. That's where you really just kind of flip the signs of the number, because these are the values that if you plug them in for x in each of those individual factors, you'd get a 0. So I've got two answers here. X could equal an 8, or x could equal a negative 9. And that's just from basic factoring. Can you give me a thumbs up if you followed along with that so far, if you remember that from basic factoring and solving? Hopefully everyone should be pretty good with that. Awesome. Now, our purpose of this original problem, though, wasn't just to solve a quadratic equation. Remember, we are trying to solve this system of equations. I don't need just an x value, but I need an x and a y. Our final solution should be, x comma y. It needs to be an ordered pair. And well, I've got these two x values, but I don't have any y values. And what this is telling us by having two different x values is that we're going to have two solutions to this system of equations. So basically, it's going to be something like the warm-up problem that we did, where you've got a line that crosses a parabola 2 times. And they're going to cross at 2 points, two different ordered pairs. And I don't know exactly what those coordinates are. So this 8, negative 9, that's not an ordered pair. Those are both just the x values. And so what we can think of is I've got two different points. One of them has an x value of 8, but I don't know what its y coordinate is. My second solution, my second intersection point of the line in the parabola, has an x value of a negative 9, but I don't know what its y value is. And so our solution will be these two ordered pairs, x and y, and a second x and y. But we just have the x values. Well, guess how we can get the y value? Very easily. Well, it just so happens that we've got several equations here that are solved for y. This tells us, how do you get a y? Well, you just plug in a value for x there, or you can plug the value in there and there. Get your y value, and you're just going to write that down here inside of your final solution for these two ordered pairs. But we have a choice to make. Which equation should we use? Well, both of them are going to give us the same answers. So you could use the quadratic or you could use the linear. Personally, I think it's going to be a bit easier using the linear equation because there's only one x there and I don't have to square it or anything. And so then to figure out the y value that goes with the 8, I would simply write negative 12 times 8 plus 36. All right, so, big math here, a double-digit number. Feel free to grab out a calculator if you would like. That is fine with me. And so you just take your negative 12 times 8 plus 36. And when you add this up, you should get a negative 60. So that tells us that when x was an 8, when x was a positive 8, we had a y value of negative 60. Well, that's awesome. Okay, so that's one solution. That's one ordered pair. So I know that this line is going to cross the parabola at the point 8, negative 60. Now, we just want to do the same exact thing with our other x value. So now I'm going to plug in the negative 9. Negative 12 times negative 9 plus 36. All right, so negative 12 times negative 9 plus 36. That gives us 144. So when we had an x value of negative 9, we have a y value of 144. Awesome. So we know that our parabola and our line are going to intersect at these 2 points. And we know we can stop right here because there can't be more than 2 intersection points, right? If we look at our previous slide, the only possibilities were 1 or 2 or 0 solutions. Well, we've got 2 solutions. I can't have 3 or more, right? A line couldn't cross this parabola more than once, or more than twice, I mean. So then that's going to be it. This is the solution to that system of equations. So in this situation, it definitely was a better choice to use elimination as opposed to graphing. Because look at these numbers, negative 60 on the y-axis and then 144 on the y-axis. Think about how far apart those are and how giant your coordinate plane would have to be to graph that, right? You're not going to rise over run over 200 units, right? That'd be pretty crazy. So the elimination technique works pretty well in this regard. All right, before I move on to the last final method, does anybody have any questions on what we did here on any of these steps? All right, think we're good? Okay, then let's move on to the third and final method. Substitution. So this last method you'll also remember from systems of linear equations. Make sure one equation, you solve it for one variable, like solve it for x or solve it for y. Right? So you get an x by itself or a y by itself, and then you simply plug that equation in to the other equation in that variable's spot. And then you're going to have a like jumbo equation, but there's only going to be one type of a variable. You're only going to have either x's or you're only going to have y's, and you simply then solve for that remaining variable. Let's go ahead and jot these two equations down. All right, is everyone good to move forward? Do you have enough time to write them down? Okay. So let's go through this method together. So step one is to solve one equation for one variable. Luckily, this first equation, see how it's already written as like y equals? That's perfect. That's telling me that, what an equal sign is, that means that, hey, this left side is exactly the same as the right side. And so if y is equal to all of this, the x squared minus 6x plus 9, that means anywhere I see a y, I could plug in or substitute in everything in that box for the y, because they're the exact same thing. So I'm going to send it to the other equation and substitute it in for that y. So instead of writing a y plus x equals 5, I'm going to write what y is equal to. So I'm replacing that y with this x squared minus 6x plus 9. So that was just the y. But after the y, remember, this is the second equation, I have this plus x equals 5. So you can see that like all of this is just that y variable. I just simply took out the y and I wrote in what the y is equal to, an x squared minus 6x plus 9. Doing this gives me a new equation. So take a look at this entire equation right here. And if you notice that there's no longer any y variables, that's perfect, because I can solve an equation if it has only one variable in it, only one letter. In this case, it's the letter x. And first thing we're going to want to do is simplify it. So I do see an x squared term, which means it's going to be a quadratic equation again. And to solve this, we always want to set these quadratic equations equal to 0, meaning I want to move everything from one side over to the other side. In this case, I'm just going to bring over that 5 by simply subtracting it. Okay, minus 5 there, then I have to subtract 5 here. So that's one thing I can do. And also, I've got some like terms now. See how there's a plus 1x here and a negative 6x? Those are both like terms. I can combine them and write that as simply a negative 5x. So our new equation, after setting it equal to 0, will be x squared. That term didn't change. But a negative 6x plus 1x gives us negative 5x. And then 9 minus 5 is 4. So plus 4, and this will now be equal to 0. All right, so I was just moving everything to one side and combining like terms. And you'll see there's another basic quadratic equation, because I can't combine the x squared with the x. Those are unlike terms. So how do we solve this? Well, we've got several techniques. I always suggest starting off by trying to factor it, because factoring is the easiest, simplest method. And so are there two numbers that can multiply to 4 and add to negative 5? How about a negative 4 and a negative 1? X minus 4, x minus 1. Right? A negative 4 times a negative 1 would equal a positive 4. But if you add those together, a negative 4 minus 1, we get a negative 5. So those would be our two factors. But remember that that's not the solution when we factor. That's not what x equals. The values for x that would make this equation true would be the opposite of each of those numbers. So instead of a negative 4, we'd have a positive 4, and over here we'd have a positive 1. So x could equal a 4 or a 1. But also don't just stop right there. Right? For this learning target, we're solving systems of equations, meaning we need ordered pairs. I need to find actual points. And this isn't a point. These are just two x values, a 4 and a 1. So if we think about it, my solutions, I'm going to have 4 comma something and 1 comma something. That's what my solution is going to look like, these 2 points, these two ordered pairs. And I know the x values of each of these ordered pairs. It's a 4 and a 1. I don't know the y value that goes with it. So what do? Well, we can simply use one of our equations that we started with. Right? I'm going to plug x into either one of these equations to get the corresponding y value. Again, you've got your own choice of which equation you want to use. Generally, I'm going to stick with the linear equation because it's a lot easier to just, subtract the number from 5 than to square it and multiply it by -6 and then add 9. So let's start by plugging in a 4. So we've got y plus, and then one of our x values that we found was a 4, equals 5. So y plus 4 equals 5. I'm going to solve this for y. We're looking for the y variable that goes with this, that corresponds to it. And well, if I just subtract 4 from both sides, we see that y equals 1. So that y value of a 1, goes with the x value of a 4, because when I plugged in a 4 for x, we got a 1 for y. So that's one of our two solutions. Then for the second one, we're going to kind of do the same thing. I'll write it over here. So y plus x, but our x value is a 1, equals 5. I want to solve this equation for y. So let's just subtract 1 from both sides, and y equals 4. So right there, when x was 1, y equals 4. That's just a little coincidence that these x and y's are flip-flops of each other. That's not always going to be true. So don't always just flip them and say, oh, that's got to be the answer. Nope, that's just a random coincidence this time, that it's 4, 1, and 1, 4. But you can box those up. Those are our final solutions. So that is where this line and this parabola would intersect at 4, 1 and 1, 4 if we were to graph them. And likewise, if I were to plug in this x and y into both equations, they both would come out true. All right, if I plug a 1 into this first equation for x squared, you get 1 minus 6, which is -5. And -5 plus 9 is 4. And sure enough, there's the 4 that goes with the x of a 1. So that's it. Those are your 3 techniques for solving systems of equations with quadratics. So exciting. Hopefully this isn't too much new material. It really shouldn't be, since we solved systems of equations with these exact same techniques just when they were lines.
The Reinhardt truck is out front. The Reinhardt truck is out front.
And so you did this back in Algebra 1. You did this at, near the beginning of the year in Algebra 2. And this is like the 3rd time you're seeing this. So hopefully it's really starting to sink in, these techniques. The one difference that we're adding on is sometimes now whenever you solve these equations, you're going to get a quadratic equation, right? You got an x squared and an x, and to solve it, you just need to factor it to get those 2 solutions.
That is actually a Pepsi truck that's out front, so I don't know if you're expecting that, but just letting you know.
And then we're also going to get sometimes 2 solutions instead of just 1. We also could have no solution. All right, so are there any questions on the elimination method? Anything that you were unsure about or that you want me to go over again, or you maybe got stuck and you're like, wait, why did he write this? Or how did we know that it was that? Okay. All right, then. Next, I've got 3 problems for you to try on your own right now. So you're going to solve these 3 different sets of systems of equations, and I want you to work through them just somewhere like in your notebook, or if you do have like graph paper, if you want to try to graph them, you can, or you can just simply use substitution or elimination with each of these. I want to give you about 10 minutes to work on these, okay? And then I'm going to go over the answers. So while you're doing that, if you do have any other questions, feel free to ask, but go ahead and jot these down, and hopefully you can get through at least 2 of them. But this is where the learning begins, right here. You trying to recreate those steps we just did, but doing this on your own now. And I believe in you. I know you can do it. All right, just a couple more minutes. Is anyone getting stuck anywhere? You can also just type in the chat if you're like, second one, and I'll go through that one or whatever if you want. All right, so let's get a visual on each of these solutions. The first one, x squared and x plus 2. If you take a look right here, I've actually got them graphed for you. And hopefully you got the solution of -1, 1, and 2, 4. Can I get a thumbs up if you got those 2 points? Cool. Excellent. Good job. And you probably didn't graph it, I'm guessing, but using those other techniques, you should still get those same solutions. Squared minus 4x minus 5. See down here, there are still 2 solutions. Did anyone get 1, -8 and 2, -9? Yes. Good, good. And the last tricky one. So, we're gonna have to really zoom out here. Whoa. All right, so this one had an intersection at -4, -41. And then, ooh, looks like, oh, fractions? I give you a fraction one? Gosh, that's so evil. And 1/3, comma, well, 2 and 1/3, or 8/3. Let's go there. All right, so hopefully you were able to get through those, at least the first 2. Those darn fractions are so evil. And I'll start working through some of them if you'd like. But before that, I do want to just preview your homework for tonight real quick, okay? So on Delta Math, you do have an assignment here. Oops, nope, not that one. On 5.4, solving quadratic systems. 4 different things for you. The first one, incredibly simple, okay? Identifying the solutions. And so literally you're just typing in the coordinates, all right? And this is me just trying to get you to associate the solution with being the intersection points on the graph. So what are the ordered pairs? So really you're just looking at the 2 different intersection points of these. And so you type in, 2, 2, and 4, 6, right? Those are the 2 different intersection points of these, and you're just turning it in, okay? So just making sure you understand that the solution of a system of equations means the point of intersection on the graphs, okay? So that's the first part, pretty simple. Then I want you to be able to practice graphing these, all right? So now you're going to graph the 2 of them, 2 equations, and then state the solution. So now you're doing 1 extra step. Now to do this, you've got a quadratic and a line that you need to graph. To graph the line, it's very simple. It's just using mx plus b. There is no line on here for you to move, but you're going to create the line starting with the y-intercept, so -5. You go down to -5, and you click 1 point, and then the slope would be -2 over 1. So from that point, go down 2 and right 1, and click, and it's going to draw the line for you. Now for the parabola, we need to do a little bit more work. All right, so to graph this, x squared plus 8x plus 16, well, we need to find like the vertex. And so if you did negative b, -8 over 2a, that'd be a -4. So I know that this is going to be over at -4. There's a y-intercept of 16. That's not on my graph, but we know it's positive, and there's no vertical stretch because there's nothing in front of the x squared. So I know it's just over 1, up 1. And so I can see there's one intersection point right here at -3, 1, and another intersection at -7, 9. And so since there are two intersection points, you have to select no solutions, one solution, or two solutions. In this case, we put in two solutions, and you type your answers in. You put parentheses, you type in the two numbers. So what was it, -3, comma 1, and -7, 9. All right, and submit that. Now, the hardest part of this one is probably going to be graphing this quadratic. So that was one of our last learning targets. So you should have learned that. You should know it. And if not, you're going to need to look back at those notes from the end of last semester on 5.3 on how to graph a parabola with that vertex form and the axis of symmetry. And then the last two, this is just solving the equations, and you can just use substitution or elimination. Plug one in and eliminate the y's, and then you select the number of solutions. All right, if there's no solutions, then you just submit it. If there's one, you're just going to type in one ordered pair. Two, you're going to type in two ordered pairs. So that's your homework for tonight, everybody. It is due at the beginning of class tomorrow. And hopefully you're able to learn something for today. And it was great seeing you all virtually. Hopefully we'll be in person tomorrow so we can actually talk face to face. But that's it for class. I'll talk to you all later. Bye.
Have a nice day.
Thanks. See you later.